In this lesson, we are going to be talking about integers. Specifically, we are going to be able to compute with integers using add, subtract, multiply, and divide. So let's first look at what integers are. So I'm going to start with the number line here in the middle. Integers are positive numbers, 0, and then the opposites of numbers. So I'm going to have 0 here in the middle. Let's put it here. So then integers would be 0. It'd be positive numbers for like 1 and the opposite of 1. And their opposites are on the equal distance from 0. 2, opposite of 2 is negative 2. So 2 to the right, 2 to the left. 3, and 3 to the left of 0, its opposite is negative 3. And then I can finish as 4, 5, over here we're going to get negative 4. And one thing I want to point out is that a common mistake is when we're working with the negative side of a number line, we tend to write it backwards. So if you notice here, as I go to the right, 0, 1, 2, 3, 4, 5, I'm getting bigger. As I go to the left, negative 1, negative 2, negative 3, I'm actually getting smaller. But if we're not thinking about this the right way, if we're just thinking of this as 1, 2, 3, instead of negative 1, negative 2, negative 3, then it does look like it's getting bigger. So be careful with that, because I see a lot of the time, if you're looking at a number line that has just negative values on it, that's where we tend to make a mistake. 0 kind of helps set us. But if, for example, I needed this to be the number negative 6, I've got to be very careful that this is negative 7, not negative 5 here, negative 8, negative 9, and so on. So be very careful when you're making a number line with just the negatives. And then let's look at these examples. Are these positive or negative? So if I am diving, going down, that would be an example of a negative value. If I'm climbing a mountain, going up higher, that'd be an example of a positive value. And a debit card, where I'm spending money that's coming out of my account, would be another example of a negative value. And then we're going to start with the rules for multiplying and dividing. Those tend to be a little bit easier. If you are dealing with two values that have the same sign, the answer will always be positive. And this goes for both multiplying and dividing. So, as an example, negative 3 times negative 4. The answer is going to be positive. In this case, positive 12. And if I have different signs, the answer is going to be negative. Again, it's the same for multiplying and dividing. An example is if I have negative 10 divided by a positive 5. So one's positive, one's negative. The answer is going to be negative. In this case, negative 2. So if they're the same sign, the answer is always positive. Different sign, the answer is always going to be negative. Works for multiplying and dividing. What gets a little bit trickier is when we get into the addition and subtraction rules. So let's start with subtraction, because what we're really going to do is we're not actually going to think of it as a subtraction problem. What we can do is we can rewrite this as an addition problem. We can do that by adding the opposite. So an example would be if I have the problem 5 minus 8. I can rewrite this as 5 plus negative 8. And these are actually the exact same expression. They have the same answer, the same values. One's a subtraction problem and one's an addition problem. So this is what it means to add the opposite. I'm going to change the minus sign into a plus, but the only way I can do that is if I change the number right after that sign to its opposite. So it was a positive 8, it becomes a negative 8. Another way we can do this is just think of that minus sign in front of the 8 as a negative. And we'll talk about that down here in just a bit. So we're going to change the subtraction problem into an addition by adding the opposite. And then we're going to come over here, we're going to follow the rules for addition because now we have an addition problem. And we've got two different rules for addition problems. So the first one is if they have the same sign. If they have the same sign, we're going to go ahead and add, use addition, and we're going to keep the sign. So, for example, if I am adding two negative numbers, negative 2 plus negative 3, I'm going to add 2 plus 3 is 5, and I'm going to keep that common sign. They're both negative, so my answer stays negative. Or I'm adding and I have two positive numbers. If I have positive 4 plus positive 5, that would be 4 plus 5 is 9. They're both positive, so it stays positive. On the other hand, we have different signs. If we have different signs, we are going to actually subtract and we want to take the sign of the bigger number. Technically, the larger absolute value, but it might just be helpful to remember as the bigger number. And an example with that would be, if we look at our original problem we had, that subtraction, we end up with 5 plus negative 8. So these are different signs. One's positive, one's negative. So we're going to subtract. And when I subtract, I wanted to take big number minus small number. So in my head, I'm thinking 8 minus 5. And 8 minus 5 is 3. So we did the subtract part. Now we're going to take the sign of the bigger number. Well, the bigger number was 8, and it was negative. So that tells me that instead of my answer being 3, my answer is going to be negative 3. So let's look at some more examples of that, because that is probably the hardest part about integers. So let's look at, for example, 7 minus 12. So let's do what we said we're going to do. We would change this into adding the opposite, so 12 becomes negative 12. Now we're going to follow that rule for different signs, because one's positive, one's negative, so I'm going to subtract a big number by a small number, so 12 minus 7, we can do that, and that's going to be 5. And then I look, what's the bigger number? Well, the 12 was bigger, and the 12 is negative, so that tells me that my answer is not just 5, but negative 5. And let's look at another one. If I have, for example, let's try 10 minus 2. Now, hopefully we know 10 minus 2 is 8. But let's just use our integer rules that we were practicing to make sure we get to that same answer. So I could have changed this to adding the opposite to see that now the 2 is negative. So I subtract big number 10 minus small number 2, that's 8. The bigger number this time is the 10, it's positive, so the 8 stays positive. So then that works. Sometimes when we add the opposite, we already have a negative. So maybe we have negative 5 minus negative 4. So in this case, when I change this to adding, and I need the opposite, well, it's already negative 4. The opposite then makes it positive 4. So now I end up with the problem negative 5 plus 4. If we simplify that, because we don't usually have two plus signs in the middle. So now I have an addition problem, so I'm going to be adding. They're different signs, so I have to subtract. Big number minus small number. 5 minus 4 is 1, so I know my answer is going to be 1. But then I look and I notice that the 5 was bigger and it was negative, so my answer is going to be negative 1. So we're going to look at this down here. Is it minus or negative? We've got 7 minus 5. Well, that's a minus problem. But it could also be a plus if I think of it as if I add the opposite. If I add the opposite, it becomes 7 plus a negative 5. So it depends on how you look at the problem, if that's a minus or a negative. Because really these can be looked at as two separate terms. The 7 is a term, and the negative 5 is a term. So it all depends on how we look at the problem and what it means to us.